Ductile iron is used for a variety of commercial and industrial applications worldwide, including vehicle parts such as steering knuckles and differential housings, underground water transport pipes, and much more. The atomic symbol for iron is Fe, and like all cast irons, ductile iron is considered a ferrous metal. Compared to other cast irons and metals, ductile iron is considered to have high strength, excellent ductility, and good toughness or impact resistance. In addition, ductile irons are considered to have relatively high machinability. In a ductile iron foundry, several different sub-processes are carried out in a carefully synchronized manner to produce quality castings. Not all ductile iron parts are made using sand molds, but many are, with sub-processes that include melting, sand preparation, core and mold making, pouring, shakeout, cleaning and salvage, casting inspection, and post-inspection processing and shipping. All cast irons produced in sand foundries undergo similar steps. However, ductile iron is unique due to an important processing step known as treatment or conversion. For ductile iron treatment, special alloys containing magnesium, cerium, lanthanum, and other elements are added to the molten metal. The magnesium reacts violently with the molten metal, and care must be taken to provide a safe work environment. When cast irons solidify, the carbon in the molten metal forms graphite. In simplest terms, due to ductile iron treatment, the magnesium combines with sulfur and oxygen and causes graphite to precipitate in spherical shape. This is why ductile iron is also known as nodular iron or spheroidal graphitic iron. The graphite shape influences the mechanical properties of cast irons. For example, here is a microstructure of gray iron, a common type of cast iron at high magnification. These long, thin flakes of graphite provide the metal with good vibration damping characteristics. Because the matrix is not continuous and the vibrations do not travel all the way through. By contrast, here is a ductile iron with the graphite in spherical or nodular form. This matrix is continuous, and although it lacks the vibration damping characteristics of gray iron, it provides ductile iron with excellent ductility and strength. Another important processing step for ductile iron and other cast irons is inoculation. Inoculation, also referred to as post-inoculation, is a process of adding inoculant-grade ferrosilicon to the molten metal. Inoculation increases the number of nodules in ductile iron and the number of eutectic cells in gray iron. By increasing the number of graphite particles, the size of the particles are reduced. These are just a few of the important steps involved in producing quality ductile iron parts and products.